Fifth one, find the value of cos 105, sin 105 and tan 105 degree. First one, cos 105 degree. I split cos 105 as 60 plus 45. 60 plus 45 is equal to 105, isn't it? So, I am splitting the value into the known values. தெரியும் 60க்கும் 45க்கும் உனக்கு தெரியும் trigonometric values தெரியும். Okay, so I split, but 105க்கு தெரியாது. So, I split 105 as 60 plus 45. And here it is cos A plus B. It is in the form cos A plus B. So, I am going to apply that formula here. So, cos A plus B equal to cos A cos B minus sin A sin B. So, cos 60 plus 45 is equal to cos 60 cos 45. In the place of A we have 60, in the place of B we have 45. So, cos 60 cos 45 minus sin 60 sin 45. What is cos 60? 1 by 2. Cos 45 is 1 by root 2. Sin 60 is root 3 by 2. Sin 45 is 1 by root 2. Here in the two terms, the denominator is 2 root 2. It is equal to 2 root 2 in the denominator. And in the numerator, here 1 into 1, it is 1. Minus root 3 into 1, it is root 3. 1 minus root 3. Okay, so 1 minus root 3 divided by 2 root 2. To make it as a value, we are going to multiply it with its conjugate. So, I am going to multiply the numerator and denominator by root 2. So, root 2 into 1 minus root 3 divided by 2 into root 2 into root 2. Root 2 into root 2, it is 2. So, 2 2s are 4. This is cos 60 plus 45. That is cos 105 is equal to root 2 into 1 minus root 3 divided by 4. So, that is root 2 minus root 6 divided by 4. We can write like this also. Now, the second one, it is sin 145. So, we are going to split 105 as 60 plus 45. So, with the same method, we are going to prove that also. We are going to find the value for that also. Okay. So, sin 60 plus 45. So, sin A plus B formula varum. You have to find the value, the homework. Similarly, tan 105. You know tan is equal to sin by cos, isn't it? Tan is equal to sin theta by cos theta. We have the values for sin 105 and cos 105. If you divide those two values, you will get the value for tan 105 also. So, you can complete the rest. Sixth problem in exercise 3.4, prove that cos 30 degree plus x is equal to root 3 cos x minus sin x divided by 2. Here we have to prove this expression is equal to this. So, cos 30 degree plus x. Here we can use cos A plus B formula. Okay. So, cos A plus B equal to cos A cos B minus sin A sin B. This identity we are going to use. So, cos 30 plus x. In the place of A we have 30 and in the place of B we have x. So, cos 30 cos x minus sin 30 sin x. Cos 30 is root 3 by 2 cos x minus sin 30, that is 1 by 2 sin x, that is root 3 cos x minus sin x. Here 2 I can take 2 as LCM, so divided by 2. That is what we have to prove. Okay. Now, here this is the first part in the sixth problem. In the second part and third part you have to do by as your homework. But before proving that, before doing that, I will give you an important value. Sin 180 degree is equal to 0 and cos 180 degree is equal to minus 1. This is very useful to you. Okay. As you know all the trigonometric values, trigonometric ratios, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. For everything you know the values. Including that, along with that, you learn this too also. Sine 180 degree is equal to 0, cos 180 degree is equal to minus 1. That is sine pi is equal to 0 and cos pi is minus 1. Then what about tan pi? Tan pi is equal to sine pi by cos pi, isn't it? That is 0 divided by minus 1 and that is also 0. Okay, so sine 180 is 0 and cos 180 is minus 1. You must know these values to do the problems. Okay, 180 is equal to pi. Seventh question, find the quadratic equation whose roots are sine 15 degree and cos 15 degree. So, sine 15 degree, what is sine 15? I write sine 15 as sine 45 minus 30. I am splitting it with the known values. 15 are known values, 45 minus 30 split பண்ணியாச்சு. Okay, so it is in the form sine A minus B. What is sine A minus B? Sine A cos B minus cos A sin B. So, in terms of A, in the place of A we have 45 and in the place of B we have 30. So, sin 45 cos 30 minus cos 45 sin 30. What is the value of sin 45? 1 by root 2. Cos 30 root 3 by 2 minus cos 45 is 1 by root 2 and sin 30 is 1 by 2. Here in both the terms the denominator is 2 root 2. What about the numerator? Here root 3 into 1, so it is root 3 minus 1 into 1, it is 1. Now next cos 15. Similarly I write cos 45 minus 30. So cos A cos B plus sin A sin B, that is the formula of cos A minus B. இங்க minus வந்தா இங்க plus வரும் cosல. So cos 45 1 by root 2, cos 30 root 3 by 2 plus sin 45 1 by root 2, sin 30 is 1 by 2. Okay, so here as well in the two terms the denominator is 2 root 2. Here root 3 plus 1. What's the question? Find the quadratic equation whose roots are sin 15 and cos 15. Now we have found the values of sin 15 and cos 15. Now we have to frame the quadratic equation. This is the general form, isn't it? X square minus sum into x, sum of the roots into x plus product is equal to 0. This is the general form of a quadratic equation if the roots are given. Now we have the roots sin 15 and cos 15. Now we should know the sum and product. So sum, what is the sum? Sin 15 plus cos 15. Sin 15 is root 3 minus 1 by 2 root 2. Cos 15 is root 3 plus 1 by 2 root 2. Again the denominator is 2 root 2. Here in the numerator root 3 minus 1, root 3 plus 1. So minus 1 and plus 1 will get cancelled and we have 2 root 3 in the numerator. Now we have to find the product. These two things we have to multiply. So root 3 minus 1 divided by 2 root 2 into root 3 plus 1 divided by 2 root 2. So for the denominator 2 root 2 into 2 root 2. 2 2s are 4 into root 2 into root 2 it is 2. 4 into 2. Root 3 minus 1 into root 3 plus 1. A plus B into A minus B. That means A square minus B square. What is root 3 square? Root 3 square is 3. What is 1 square? Minus 1. 4 into 2 it is 8. So 3 minus 1 it is 2, 2 by 8. 2 by 8 or I can write it as 1 by 4. That is the product. Now we can substitute this in the quadratic equation. So that quadratic equation is equal to x square minus 2 root 3 by 2 root 2. 2 2 will get cancelled, isn't it? So root 3 by 2. Root 3 by 2 into x plus 1 by 4 is equal to 0. To make it as a proper equation, we can take 4 as LCM. So, if you take 4 as LCM, this is 4x square minus here plus 1. What term will come here? You have to multiply this to make root 2 into 4. You have to multiply it with 2 root 2, isn't it? You have to multiply it with 2 root 2. 2 root 2 means root 2 into root 2 it is 4. 2 into 2 it is 4. You can make it 4. So, in the numerator also you can multiply it with 2 root 2. So, root 3 into 2 root 2. What will be that term? So, root 3 into root 2 will become root 6. So, it is 2 root 6x plus 1 equal to 0. That implies 4x square minus 2 root 6x plus 1 is equal to 0, and this is the required quadratic equation whose roots are sin 15 and cos 15. Expand cos A plus B plus C, hence prove that cos A cos B cos C is equal to sin A sin B cos C plus sin B sin C cos A plus sin C sin A cos B if A plus B plus C is equal to pi by 2. We have to expand cos A plus B plus C. So, cos A plus B plus C. We know the formulae for 2 angles only. Okay, but here it's given that 3 angles, cos A plus B plus C. So, I split it as cos A plus B plus C. A plus B plus C. I take B plus C as a single angle. So, cos A plus B plus C. Now, it is in the form cos A plus B or cos alpha plus beta. Now, we can expand that. So, cos A cos B minus sin A sin B. இதை வந்து B plus C ஒரு angle treat பண்ணிக்கணும். Okay. So, cos A cos B minus sin A sin B. That's what we have written here. Now, in the next step, keep cos A as it is and cos B plus C, expand cos B plus C. Here, while expanding cos B plus C, I get cos B cos C minus sin B sin C. Similarly, here minus sin A, keep sin A as it is and expand sin B plus C, sin B cos C plus cos B sin C. Now, you can multiply it inside cos A inside these 2 terms and sin A into these 2 terms. So, I get cos A cos B cos C minus sin B sin C cos A minus sin A sin B cos C, multiply பண்றோம் sin A sin B cos C minus sin A sin C cos B. Okay. Now, this is cos A plus B plus C. We have expanded it. Now, a condition is given there A plus B plus C is equal to pi by 2. So, it's given that A plus B plus C is equal to pi by 2. We have cos A plus B plus C. So, cos A plus B plus C is equal to cos pi by 2. I take cosine on both sides. Okay, cos pi by 2. What is the value of cos pi by 2? Cos 90 degree is equal to 0. So, this is equal to 0. This whole, the cos A plus B plus C is equal to 0. So, the whole expression is equal to 0. So, cos A, cos B, cos C minus sin B sin C cos A minus sin A sin B cos C minus sin A sin C cos B is equal to 0. While equating this is equal to 0, I keep this term on my left and all negative terms to the opposite side. So, okay. So, cos pi by 2 equal to 0, substitute in 1. That implies cos A cos B cos C and that's equal to, I am bringing all the terms to the right, that is sin B sin C cos A plus sin A sin B cos C plus sin A sin C and cos B. Okay, so I'll bring all the terms on my right. So the given expression we have gotten or the given expression cos A cos B cos C is equal to this one. Hence the proof. First subdivision in 9th question. Sin 45 plus degree minus sin 45 minus degree is equal to root 2 sin theta. We have to prove this result. First I take sin 45 plus theta. Sin A plus B. What is sin A plus B? Sin A cos B plus cos A sin B. Okay. Sin 45. What is sin 45? It is 1 by root 2 cos theta. Plus cos 45 is 1 by root 2 sin theta. Now I take the second one, sin 45 minus theta. Sin 45 cos theta minus cos 45 sin theta. Sin 45 is 1 by root 2 cos theta minus 1 by root 2 sin theta. Now I will take the left hand side, sin 45 plus theta minus sin 45 minus theta. Okay, so here you can substitute the values. For sin 45 plus theta you can substitute this minus sin 45 minus theta. As it is minus, I am going to change the signs of the second expression. Minus 1 by 2 cos theta plus 1 by root 2 sin theta. Okay, so plus 1 by root 2 sin theta minus, no, plus 1 by root 2 cos theta minus 1 by root 2 cos theta will get cancelled. So it is 1 by root 2 sin theta plus 1 by root 2 sin theta. While adding this 2, you get 2 by root 2 sin theta. 2 by root 2 sin theta. 2 and root 2 will get cancelled. So 2 will become root 2. அப்படிதானே 2 root 2 into root 2 னு எழுதலாம். So root 2 and root 2 will get cancelled. So it is root 2 sin theta, and that is our RHS, and hence we have proved the result. What is more important? You should know the formula more clearly. If you know the formula, then you can substitute and simplify it. So, okay, thank you. 12th problem. Prove that sin 75 minus sin 15 degree is equal to cos 105 plus cos 15 degree. First, we take this sin 75. Sin 75 can be written as sin 45 plus 30. That is sin A plus B. Sin A plus B formula is sin A cos B plus cos A sin B. So, sin 45 cos 30 plus cos 45 sin 30. Sin 15. Sin 15 is equal to sin 45 minus 30. That is sin A cos B minus cos A sin B. Sin 45 cos 30 minus cos 45 sin 30. Now, we have sin 75 minus sin 15. Okay, so we are going to subtract these two equations. So, sin 75 minus sin 15. While subtracting, okay, here this will be minus and this will be plus, isn't it? So, sin 45 cos 30 minus sin 45 cos 30 will get cancelled. Here cos 45 sin 30, this will also become plus. While subtracting, we will change the sign. So, it is cos 45 sin 30, that is equal to 2 cos 45 degree sin 30. We know the value for cos 45 and sin 30, that is equal to 2 into cos 45 is 1 by root 2, sin 30 is 1 by 2. 2 and 2 will get cancelled, that is equal to 1 by root 2. This is our left hand side. Now we have to find the value for our right hand side. In our right hand, we have cos 105 and cos 15. Cos 105 can be written as cos 60 plus 45 degree. And you have to expand this according to cos A plus B form. So, cos 15 can be written as cos 60 minus 45 degree. Here you have to expand it in cos A minus B form. So, cos 105, that is cos 60 plus 45 It is in the form cos A plus B. So cos A cos B minus sin A sin B. That is cos 60 cos 45 minus sin 60 sin 45. Cos 15 can be written as cos 60 minus 45 and its expansion is cos 60 cos 45 plus sin 60 sin 45. Now we have to find cos 105 plus cos 15 degree. So we have to add this too. While adding this, minus sin 60 sin 45 here plus sin 60 sin 45. Both of them will get cancelled and here we get 2 cos 60 degree cos 45 degree. That is equal to 2 into cos 60 is 1 by 2. Cos 45 is 1 by root 2. So 2 and 2 will get cancelled. We get 1 by root 2 and it is our equation 2 and this is the value for our right hand side. So by 1 and 2, here also in the left hand side we get 1 by root 2. Similarly on the right hand side also we get 1 by root 2. So from 1 and 2 we had left hand side is equal to right hand side. So hence we have proved the given result as sin 75 minus sin 15 is equal to cos 105 plus cos 15. Show that tan 75 plus cot 75 is equal to 4. So tan 75, I write tan 75 as tan 45 degree plus 30. It is in the form tan A plus B. What is tan A plus B? Tan A plus B equal to tan A plus tan B divided by 1 minus tan A tan B. It is a formula for tan A plus B. Okay, so now we are going to write the given thing in the form of this. So tan 75 degree is equal to tan 45 plus tan 30 divided by 1 minus tan 45 tan 30. What is tan 45? It is 1. Tan 30 is 1 by root 3 divided by 1 minus 1 into 1 by root 3. We take root 3 as LCM. So you get root 3 plus 1 in the numerator. Similarly here 1 minus 1 by root 3. So if you take root 3 as LCM, in the numerator you have root 3 minus 1. In both the terms the denominator will get cancelled. Denominator is same, root 3. So it is root 3 plus 1 divided by root 3 minus 1. That's the value of tan 75. Now we have to find the value of cot 75. So cot 75 degree is equal to 1 by tan 75. So 1 divided by this value, that means the reciprocal, isn't it? 1 by tan 5, so the reciprocal of this value. So I write it directly, root 3 minus 1 divided by root 3 plus 1. We have to add this too. So tan 75 plus cot 75 degree is equal to root 3 minus root 3 plus 1 by root 3 minus 1 plus root 3 minus 1 divided by root 3 plus 1. Okay. So we'll take root 3 minus 1 into root 3 plus 1 as LCM. Here in the numerator, you have to multiply this with root 3 plus 1. So already root 3 plus 1 is there in the numerator. So root 3 plus 1 square plus here root 3 minus 1 is there already. So it is root 3 minus 1 the whole square. Now we have to expand, that is equal to here a plus b the whole square. So a square A square is 3 plus B square, it is 1. 2AB, that is 2 root 3 plus, here root 3 minus 1 the whole square, that means A minus B the whole square. So A square 3 plus B square 1 minus 2AB. So minus 2 root 3 divided by A plus B into A minus B, that is A square minus B square. Now look at the numerator. Here 3 plus 1 4, 3 plus 1 4, 4 plus 4 is 8. 2 root 3 plus 2 root 3 minus 2 root 3 will get cancelled, divided by, here root 3 square, that is 3 minus 1. So 8 divided by 3 minus 1 is 2. So 8 by 2, and that is equal to 4. So we start simplifying from the left hand side and we get 4, and that is our right hand side. So hence we have proved the given result.